Hi, and welcome. Thank you for spending the next 30 or so minutes with us. My name is Valerie DiMartino. I'm Director of Product Marketing at NetBrain, and I'm joined today by Dave Spence, Senior Pre-Sales Engineer at NetBrain. Today we're here to help you better understand the opportunity of network automation as it relates to network intent to diagnose slow applications to help prevent downtime. So first, why does this matter? You may have heard that downtime is the new outage. In fact, downtime is more prevalent than those headline-making outages for sure. But what is the real cost of downtime? It's actually higher than you would think. According to Gartner, by 2025, 60% of organizations will have seen a reduction in traditional network monitoring tool needs due to an increase in remote work and cloud migration as compared to last year. And according to an ITIC survey, 44% of mid-size and large enterprise respondents reported that a single hour of downtime could potentially cost their business over $1 million. That's quite profound. So let's take a minute here and actually talk about what day 2 operations is in this webinar. So what we consider day 2 operations is really all the time after your provisioning and configuration of the network is complete. So this is a really long, important period of time that encompasses all the day-to-day operations of your network. And we truly feel that this is an area where we can help NetOps better align with the business needs and reduce costs. So let's talk about network intents here. First of all, network intents manage expected results of the network. So what do you expect the network to be doing, and is it still doing what you expected? And this is instead of relying on traditional device level management approaches. So we take this top-down approach and we abstract what we consider to be intents, which are really the reason that those devices exist and are put in place in the first place. So the intent is defined as the intent of your live network, and additionally, it's the associated diagnostic logic to detect deviation from those intents. So what we're doing is we're managing the network as a collection of thousands of intents, tens of thousands of intents, not just 1,000 devices, if you will. And that's really the path forward to network automation. That's really the key to doing this at scale. So what we're doing is we're abstracting the underlying network details and we're translating those business intents to network intents. And then ultimately we're translating them to the device configurations themselves. So we're combining these network intents with automation, and specifically day 2 network operations is then more scalable. And this is really a huge value in this era of constrained skilled resource availability. And NetBrain differs drastically from really all the other device-based network management approaches because it's focused on application needs and services in use. So we developed our problem diagnosis automation system, which is our PDAS platform, to manage hybrid networks as a compilation of network intents to directly support IT service delivery needs. And this day 2 automated network operations allows you to manage your hybrid network by capturing, verifying, and enforcing network design intents. And this eases problem diagnosis to ensure that the conditions that you expect are maintained in your network. And we've also included an intent library that offers more than 60 of the most common intents from our largest customers for your modern enterprise network operations. So we're really lowering the barrier to adopting and starting with network automation. So we've spent a lot of time talking to our customers, and we've really learned what their top 8 network challenges are for day 2 automation specifically. So we've been doing this webinar series on intent-based automation to focus on these specific use cases here. And so today's webinar is really going to focus on how intent-based network automation is going to help diagnose slow applications that are a result of the network. So NetBrain's really spent years with hundreds of developers creating intent-based automation technology, and it's proprietary, by the way, because we truly believe that it's the path forward to making all things NetOps better. So by building an intent in a path, the function of an application path will be integrated with the functions of the network intent, and this is really going to lead to more efficient troubleshooting. So path intent is what we call it, and it promotes simpler power user workflows. So while troubleshooting the application, you can review the baseline path and the path intent results, rerun the associated path network intent with live network data, and then check the diagnosis results. So this is our path troubleshooting workflow. And then you can calculate, define, and benchmark all of the optimal traffic paths as golden paths. So this is really your baseline. And then you can compare these against active application paths and discover any deviations much more easily in a visual map type of path view. And so what we've enabled you to do is really create intents on the fly. And we've done this through a new technology that we're introducing this month called Auto Intent. And this is in our latest release, Release 11, which we're going to have a webinar on October 19th. So go ahead and sign up for that. And Auto Intent is this new foundational technology that lets you compile all the diagnosis and parsers associated with intents in a modular building block framework. And you can visualize the results of the intent by devices on a map. So you can really just pick and choose by device or by intent and build out the diagnostic logic on the map itself and run the diagnosis right then and there. And compare it also with the baseline and against historical. So lots of really rich capabilities here with application pathing. And now we've added a third dimension, which is context. So we're not just looking at a two-dimensional flat network, up or down status. We're actually trying to understand the complete understanding of path quality in the context of the application that you're delivering with the network. And we're doing this by leveraging design network intents, which are defined as baseline, topology, state, and condition. And this lets you automatically verify and enforce every application path. So you can calculate, define, and benchmark all the optimal application traffic paths as golden paths, and then compare them against the application paths to discover any deviations. And this gives you a contextual understanding of qualitative conditions for real-time and interactive multimedia applications. So as you know, VoIP and video are sort of the heart of communications today in enterprises, and so it's imperative that these have the most strict quality of service measurements applied to them. And then you can see a complete history of all of your automated checks performed at regular intervals. You can go into the history and look at all of those timestamps and determine when any changes occurred and why they were done. When issues with applications or services occur, you guys, the network engineers, rarely ask yourselves the state of CPU or memory usage on each network device or the status of every network link. But end user experience is really more complex. It's a whole range of qualitative conditions that go far beyond connected or disconnected. That means you have to ask application-specific connectivity questions concerning latency, jitter, and other qualitative dependencies to get to the root cause. Take, for example, users that can access a critical web-based application, but the performance is so slow that it impacts the overall productivity and customer satisfaction. Say that application is from the real-time interactive multimedia application class, like VoIP or streaming video. So any problems in the network are magnified dramatically. So while connectivity exists, the quality of those connections varies widely. And network support teams know full well that assuring services on the network is much more than verifying if devices and interfaces are up. So we have our application assurance technology here, which goes ahead and checks for connectivity and adherence to the golden path, which is the healthy path, and intent verification. So it's checking the intent and verifying that it's being met with the current path. And if it's not, it's going to tell you the exact diagnosis. It's going to give you edge to cloud network topology discovery with path validation and, like I just said, performance checks to verify end-to-end connectivity of the path flow. And then you're going to get a single dashboard that shows the health of all business critical application paths. So all in one, you're going to see every single critical application path in a single unified dashboard. And you're going to get the historical mapping at your fingertips. So it's really not about more tools. You just need an intent-preserving integrated solution. So NetBrain's Application Assurance Dashboard, the Application Manager, displays all of your applications and their network paths and intents in one single screen. All the paths are organized by applications or services. And with Application Assurance, you can view the status of path and intent checks, statistics on failed or changed paths, and filtered rows based on results. So you can perform network investigations quickly with path calculations and mappings, creation of new applications and paths, or importing and exporting of application and path data. The dashboard is really one-stop shop to provide you with assurance that the network is consistent as required by your critical applications. And then we have historical change visibility, allowing operators to see a complete history of all of the automated checks that it continuously performs at regular intervals that you schedule over time. So this really provides you with the ability to quickly troubleshoot and diagnose application performance at the traffic flow level. So application assurance augments the typical but rudimentary A to B path checks with network intents to provide a full assessment of the health of the network in the context of all business critical applications, so that you can maintain network design compliance by verifying application path health and any deviations from the intent. You can really get alerts. It's truly set it and forget it. So you get any alert when any intents are deviated, and then centralized management, as I just spoke about, in a single unified dashboard with all application paths consolidated for your visibility with all the statistics that you need, and it's exportable. And then flexibility, really any underlying infrastructure, any vendors that you are using in your network, we support. So edge to cloud, SDN, SD-WAN, any application, it's all supported. So Dave is going to give you an in-depth demo in the next couple minutes here on diagnosing slow applications. So the background is that the application is slow and we want to know if it's the network or not causing it. So we're going to provide real-time capabilities to diagnose a slow application, which is really a lost art that the industry just can't afford to be without, given the cost of downtime today and the impact that it has, even more so than a large impactful outage. So he's going to really talk about visualizing the path, baselining the routes and utilization, and identifying any changes through health checks against intents. He's going to show you the dashboard, and he's going to really show you how you can set up preventive automation to manage this for you while you go off and work on really more important, scalable, interesting tasks. So here, over to Dave for the demo.
Thanks for the introduction, Valerie. So I'm Dave Spence, Senior Pre-Sales Engineer at NetBrain. Now, I'm going to take you through a fairly in-depth demonstration of network intent and how it can help you troubleshoot slow applications. Now, we're going to have a quick look also at NetBrain's application assurance module, because as the name might suggest, this can also really help here. But first of all, let's start at the very beginning. So imagine we've got a user, and this user is experiencing really poor performance from, say, their WebEx application. Now, what we can do to troubleshoot this is to use NetBrain's A to B path calculation tool. And what this can do is map out all of the network devices which are used to transport this application. So let's have a quick look here at some of the options. So actually, first of all, we can select whether the path type is unicast, or in fact, it could be multicast. We could also specify the different protocols which could be used here. So this could be IP, TCP, UDP. In fact, if I just show you here, we actually support quite a large variety of different protocols here. And in fact, if I'd have selected TCP here, then I'd get the option here to actually put in ports. And that can be really useful if you're troubleshooting a particular path and you want to ensure that there's connectivity to a particular port on the destination server. Let's just go back. So it's worth also mentioning here that you can actually decide what data source you want to use. So you can map this path live from the live network. You can map it from NetBrain's digital twin, what we would call the cache, or you could do this for historical data. Now, for a production environment, it's probably best to go live because you want to know what's happening right now. But actually, for a demo, it's always better to do cache because it's quicker. And that's in fact what I've done here. Now, it's important to understand that all of this, it's not just a simple trace route. This is a NetBrain A to B path. And actually, if I go down here and say have a look at the firewall and click the path details, we can actually see what's going on here. So we can see that NetBrain, first of all, actually, it's looking at things like the routing table. How is this particular device forwarding that traffic? So for things like routers and firewalls and layer 3 devices, NetBrain's actually looking at things like routing tables, the layer 3 forwarding tables. But actually, for things like switches, it'll be looking at the MAC address tables. But also here, look, NetBrain's looking at the ACLs, the policies. So how is this firewall actually dealing with this traffic? Like I said before, if I'd have picked something like TCP rather than IP, it would actually examine the port as well. So it would understand whether that traffic was permitted by that particular device, by that firewall. And if it wasn't, then, and if it was denied, then actually the path would end there. So rather than getting a nice little message like we've got here, a little note on the map saying, oh, traffic's being permitted, it would say traffic was blocked and the path would just end. And that would be the end of it. And another big advantage we have here from using A to B pathing as opposed to, say, a trace route is that NetBrain understands the layer 2 hops as well. So we can see here, look, we've got an extra switch over here, US BOSS switch 3, which would be invisible, if you like, to tools like ping and traceroute. So it's important to get this, that by troubleshooting a slow application path using this A to B pathing tool, we can massively reduce the troubleshooting by identifying exactly the devices which are used to transport the application in that path. And we don't have to worry about anything else. We've now isolated that just to these devices. Fantastic. So what we can do now we've isolated these devices, now we've created a map showing all of the devices which are carrying our traffic for this application, we can use this as a GUI for automation. So for example, what I can do over here is I can run an overall health check. And I've got a few options here. I could pull data regularly and I can specify the period and how many times. Or I can just run it once, which is what I'm going to do now. And so I can check these devices to see if there's anything obviously wrong here. Yeah, so let me just move this up. So we can see here, look, we can see things like CPU utilization. That's interesting. Let's have a look, see what's going on here. We actually get quite a nice graph here showing us the historical data and how this has varied over time. But again, it's good because it's visual here. So we can actually see green is good, red is bad. Everything seems to be up and ready, and green all seems to be good at the moment. So there's no obvious problems. What we can say at this stage, well, at least all of these devices are functioning. So my traffic seems to be okay at getting from point A to point B. So what we can do here is dig a bit deeper using something called network intent. So let me just clear a bit of space over here. And what I'm going to do here, if I go back under my runbook, I'm actually going to add a network intent node. Okay, and I'm going to add 3 network intents, which I've prepared. 1, 2, 3, and we're going to go through these in turn and have a quick look at these. Okay, so the other thing we can do first, actually, before I do this, before I forget, because this is also very useful, is that if you think about this path that we have here, this path, it's an A to B path, it's showing all of these devices, and you've got all of this useful information. But if you look here, I've got a path intent as well. So actually, what I've got here is a network intent created for the path to verify that everything is working as it should. Now, this could be testing any particular aspect of the path that could be considered important for the health. Yeah, so it could be testing something perhaps like quality of service. It could be looking at routing hops, checking for loops perhaps. Yeah, maybe MTU values. In fact, any parameter really that we need to check in order to have confidence in the performance of this path. And I just wanted to show you that before I dive into those network intents. And actually, if we look quickly here, yeah, we can see that even though we know, look, because everything's green, that we've got path connectivity, we've got an intent violation. Yeah, we've got a queue drop. Now, this is really useful, huge really. I mean, imagine the amount of finger pointing when you've got a slow application. So the server team wants to blame the networking team wants to blame the server team, etc. But here, we can quickly verify if there's anything wrong with the network or not, but in particular, anything wrong with this path. That's really important. So sometimes, if you think about it, it's as much about mean time to innocence as it is to mean time to resolution. Though to be fair, the network doesn't look very innocent at the moment, and we're going to have a look and dig a bit deeper. And let's go into those intents that I added. Okay, so let's go in here. So these are specific ones which I created for the purpose of this demo. Okay. Now let's have a look at one. So which one can we go in here? Let's check the ACLs at the top. Yeah, so what is a network intent? Well, a network intent is made up of 3 components. And in fact, if I show you here, you can see the first one. So the first component are the devices. So that's the devices which are in that network intent. And in this one, it's about ACLs. So these are layer 3 devices. I've got a couple of routers, and I've got a firewall. Yeah, and actually, if I go in here, yeah, you can see that here. And this is a bit better. So the first part is the first component are the devices. The second part is the data. And actually, if I show you this here, what's a good one to go into? Let's just go into the top one here. So if you go in here, you can see the data. It's the access list configuration from the config files. Yeah, that's the second part. So we've got devices, data, and then the third part is the diagnosis. So you can see we're taking this here. So we're saying this is our golden ACL. This is what it should be. And we're doing the same thing for our firewalls as we are for the routers. And then here under define diagnosis, what we're doing is performing a diagnosis saying, look, when I run this network intent, if the current value for that section of the configuration file equals this baseline, this golden baseline that I set up when I created the network intent, all's good with the world. And everything's green. Brilliant. Alternatively, if it does not match, then we've got a problem. Somebody's changed it. Yeah, so that's quite good here. So you can see this has been run in the past, but I'm going to go ahead and I'm going to run this now. So we can see this now. So it's running ahead and it's verifying, do my ACLs match their golden configurations? And thankfully they do. All is good with the world. And in fact, we can have a look here under this diagnosis tree. So the diagnosis tree for the intent, think of it really as an execution path. So what you can do with a network intent is specify that depending on the conditions, if they are consistent or if they're not consistent, then trigger some other network intents, dig deeper into some secondary network intents. And as you can see here, actually the ACLs are consistent, so these extra intents were not executed. Okay, so that's brilliant. Our ACLs are consistent, so these intents weren't executed. Fantastic. So let's have a look at the next one. So what have we got next? We've got the interface errors check. Let's go in here. So what this is doing, oh, this is looking good. What this is doing here is to use the show interface command. Let me go in and actually edit this so I can actually show you what we're doing here. So this is using the show interface command on these devices in the path to look for different errors on the interfaces. So you can see here how the intent is extracting these different errors from the output of the show interface commands on a per interface basis. So I'm specifying here, I'm using a paragraph variable, and so I'm saying, look, interface is status, so I'm replacing the variables, if you like, what's changing with variables. And then I'm saying, actually, within that line, this is my variable line pattern. So I'm extracting things like input errors, look, and I'm extracting things like CRC, output errors, and collisions. Okay. Now, what's really important here is that there's no coding. This is absolutely magic, really. I mean, there's no coding, there's no regular expressions. It's intuitive. All you really need to do is replace the values that you're interested in with variables. Let's have a look now at our diagnosis. So what are we actually looking for here? So what we're doing in the diagnosis is we're looking here to say, look, if my input errors or my CRC errors, in fact, any of these guys, if any of them are greater than the last time this intent was run, well, that indicates that these errors are increasing. And I'm tying this together with a Boolean expression to say, actually, if these errors are increasing since the last time, I've got an issue here. So I'm doing it rather than the other way, where I was the first one, if it equals this, then it's good. Here I'm saying, well, actually, if it equals the conditions here, then it's bad. Yeah, I've got interface errors increasing. And you can get quite sophisticated here as well. Yeah, and I can specify, I haven't, but I could have specified follow-up intents as well. That's what we saw earlier with the diagnosis tree. So again, I'm going to run this just to see what we've got. Okay. So last time, if you remember, when we ran this, we saw that there were some errors. And again, we can see that again here. And what's particularly good here is it's specifying the interfaces where we've got the errors. So you can go in here, look, and if I just click one of these here, we can see US boss R1. This is what the value is now. 198,523 for the input errors, compared to a smaller value last time this intent ran. And actually, if you hover it over here, it gives you this information. Interface errors present on Ethernet 0/1. Okay. So again, look at that detail. Yeah, we're told the interface, the type of error, and the exact values. Brilliant. Okay, so let's have a look at our next network intent, which is a latency check. Let's go down here. Okay. So let's just have a quick look at this. And this is actually a relatively simple network intent. And what I've done here, let's just show you, is I've got each individual device on the path here, just pinging its neighbor. Pretty basic stuff. We're all familiar with ping. And if you look in here, it's a ping command. So ping my neighbor. I'm extracting here. Look again, very simple, very intuitive. No Python scripting involved. I'm extracting here the percentage rate, should I say, and also the minimum, average, and max round trip times. And you can see all of those values here. And then what I'm doing is I'm performing a fairly basic diagnosis. So, well, actually, if they're greater than, say, 5, which is a fairly arbitrary value, but that's fine for our lab, then we've got a problem. But I can also use their names. I can actually put information here. And this is what I did for the last one as well. I can put in variables to specify the particular device so that if there is an alert, I get that bit more information. So again, I can click run and let's see what we've got. Again, everything's good. Everything's green. I like it when things are green. So we can see here, everything's fine. The value is 1. Yeah, rather than 5, which is the value we specify. So everything's absolutely brilliant here. Yeah, latency normal between these two devices. And again, if you think about this, this is really helpful because when you're troubleshooting and you're just using a normal ping, the ping does end-to-end, and that's fine, and it can highlight a problem. But actually, what you really need to know is where that problem is. Where is that bad latency? And so we've got that here. We can actually say, well, actually, if there was a problem, because there isn't from that perspective here, we can say, it's between these two particular devices. So again, that's actually really, really helpful. And in fact, just quickly whilst I'm here, if you wanted to here, you could just click run, it would run all 3, and you'd see all of that nicely together. Yeah, and we should say here in a second, this should nicely go red for us in a minute, showing us in fact that we actually have some interfaces, some interface errors here. Again, sometimes the GUI lags a bit. Oh no, it hasn't this time. That's really good. So again, if you think about this again, I executed this really shortly after I previously executed it. So it's looking for deltas between this time it's run and the previous time. So there haven't been any interface errors. That's actually really good. So it shows you this is dynamic. It's comparing it with now with the previous time. Rather than the others, they're actually comparing the values with the baseline. Brilliant. So what can we look at next? Yes. Now this is quite key. So as well as having the idea of a network intent and in fact a path intent, we can also vary the entire path against a golden path. So that was quite key if you remember. When we're looking at the network intents, I was comparing it against baselines. But actually, yeah, that's fine. Well, that's the baseline for particular values. But what about a baseline for the entire path? So I can get that here actually. If I go back in and view these details for the path. So this is our cache. This was the value we got from the baseline. But actually, I can say, look, can you draw this golden path? This is the correct path. We're going to have a look at this in a little bit more detail in a moment. but actually I can get NetBrain to actually draw the perfect path, the golden path, the ideal path, the intended path. Okay, so we can see here, if I just have a little bit more space here and just remove this, what we can actually see over here is that the intended path, if you like, the golden path, goes through this MPLS network, rather than what it's done in our case, which is to go through the VPN. So actually this is brilliant because we know exactly what's happened here. So our path, rather than going over our beautiful low latency MPLS network, it's now going through our DMVPN. And again, when you think about voice and video traffic, it's incredibly delay sensitive. Latency is really important to that type of traffic. So we can see here, actually, that may well be the reason that maybe somebody raised a ticket and said, oh, actually, my WebEx traffic is a bit choppy. It's working. And we can see it works because the path is actually fine. But actually, if it's choppy, that's probably why. It's going through the VPN network rather than our MPLS. So if you think about what we've done so far, we've shown how a network intent can really help troubleshoot slow applications. We've done quite a bit, really. We've done the pathing, we've done overall health views, we've done the intents, and then we've shown the golden path. But when you think about it, it was all a little bit manual. I mean, yes, it was automated, but it was still run by me. So wouldn't it be great if this could be triggered by an event? Wouldn't it be brilliant if we could say, set up a ping, and if the latency reached a certain point to say our WebEx server, it could trigger these intents to verify the cause. Well, actually, we can, thanks to NetBrain's Preventative Automation Manager. So let me show you that here. Here's one I prepared earlier. So if you look here, we can see a number of network probes. Now, you can sort of think of a probe as like a mini intent. Yeah, so let's have a look at one down here. So this is a probe, which I've called latency check, but it's a probe this time. And I created this earlier as an end-to-end probe. So if you remember, this is with the switch at the branch, and this is pinging our WebEx server. So this is pinging it, and actually what I've done, if I actually show you this here, and in fact, you can see this down here, look, ping 10.8.1.26. So what this is actually doing, this is pinging our WebEx server, and I'm extracting this average value here. So look, I'm extracting it here, look. Yeah, and if that's greater than, say, 10, then we've got a problem. Yeah, and it's going to trigger an alert, and it's going to say latency high to WebEx server. And actually, if I go here, you can see back on here, this is running every 10 hours, but I could reduce that. Yeah, I could run this more frequently than required, but actually, to be fair, to break the fourth wall a little in this demo, I configured this myself so that my inbox wouldn't be overwhelmed by emails. So I deliberately set at quite a low value, just so that we could get some emails, and I'll show you quite a nice alert email in a moment. And actually, in a production environment, rather than setting something quite slow, because actually low, 10 milliseconds is pretty low, really, going across maybe a VPN or an MPLS network to a distant location. So in reality, you'd probably check for a larger value than that. And you'd also probably use a much shorter frequency than, say, 10 hours. But if I go back to the demo, we can also see here, look, we're sending an email. So I'm sending an email to myself. Yeah, enable email notifications when the flash probe has alerts. And I've got one of those all nicely here. So let me just drag this across. So this is one I set up earlier, or rather it's sent to me. So this is showing you, look, the probe name, the flash alert, the first time and the last time it ran. And it's even giving me a link here to the map. So I can open the map and view that. So that's really helpful. Yeah, actually, there's more, though, that I want to show you, because if you go over here, and if you look here, look, under triggered automation, you can see here that this is also triggering our, and when it says automation name, this is our network intent. So what this is doing here is actually triggering that network intent we created. So if the latency across the path is, say, greater than a certain amount, then it triggers this network intent, which is then verifying that hop by hop latency. And in fact, we could have even triggered multiple network intents using a network intent cluster. So you're not just limited to one intent. So the key here is that by checking for events like this and then going ahead, running an intent and just digging a bit deeper, we can hopefully detect an issue before the users are reporting on it. That's really key. And then hopefully we can solve it. And that's really driving down that mean time to resolution. Because if you're working on a problem before the users have even reported that, then it's going to be resolved a lot more quickly. None of this waiting around in a ticketing system for somebody to come along and look at it and the time it takes for somebody to notice it. we're on it straight away. And that's why we call this preventative automation. So to finish off, what I really want to look at now is our application assurance module. So let's have a look at this over here. So if you think about what we've done so far, we've just been looking at one path. Okay, we looked at it in quite a bit of detail, and we did quite a bit on that path to troubleshoot any serious issues which might impact our applications. But actually, a typical business is going to have a lot more than one path. It's going to have dozens typically, if not hundreds. So the application manager, which we can see here, allows you to view all of your critical applications, and actually more importantly, the paths, on a single dashboard. So we can see the result over here, look, path result, did it succeed, did it fail? Most of these have succeeded, which is pretty good here actually. Yeah, and actually we can view the history. So let me pick one here. This is a good one. Yeah, so again, we can see here initially it failed, and then we've got some succeeded paths. And actually this one is our golden path. Yeah, and actually I've mentioned golden path. So in terms of the result, how did the last result compare against the golden path? As we can see here, it's changed. It was successful, but it wasn't the golden path. And in fact, it's changed since the previous one. So something's going on here, actually. We perhaps had a path fail over here. Brilliant. That's really good. And actually, what we can also do here is see the result of the path intent. So did the path intent have any alerts? Was it successful? And again, we can see here, no alerts. So brilliant. What we can also do here is schedule these. So if you go here, what we can do is actually schedule our application assurance module to actually verify those paths, regularly verify those paths on a scheduled basis. Yeah, so you can see here, I've got a couple here, and I've also set up an alert setting to email myself if there's a problem. And in fact, this is the type of email you typically get for that. So you can see here, we've got 12 paths were successful and a couple of paths failed, and 7 paths changed with the golden path. So again, it's giving me all this useful information that I need to know so I can have confidence that all of my critical applications are running as I want them to. So I think that's pretty much it. I think we've wrapped up really. I mean, we've covered quite a bit actually. So thanks for staying with me throughout this demo. And what I really wanted to get across here was that the performance of your critical applications are essential to the success of your business. So NetBrain can help you troubleshoot these applications by automating and verifying your critical paths using network intent, NetBrain's A to B pathing, and of course the application assurance module. So once again, thanks for staying with me and thanks for listening.
All right, great demo, Dave. Thank you so much for all that valuable information. So I want to provide you with this scannable link, QR code, and a link to getting started with us. So we have a test drive as well as a lot of resources on our site. We've got a lot of information about our latest release, future webinars, including the What's New webinar coming up later this month. So please go and check it out. Check out some of our brand new web content. And I think right now we're going to go ahead and take some Q&A. So let's go ahead and do that. And thank you so much again for your time today. Please go ahead and put your questions in the chat. We're going to go ahead and take those verbally right now. So our first one, actually, we have a couple on this one. The application manager, I have George here with me, who's another a demo engineer to help answer some questions. The application assurance module, can we talk about how the customers can or prospects can go ahead and get a hold of that and try it out, and if that's a separate module?
Sure. So the application manager is a additional module to the core NetBrain product. So if you are already a current customer, then you can reach out to your account executive to get more information on pricing and adding this module to your NetBrain environment. And then you can also reference our website for, if you want to get a demo, you can go to our website to look at application manager. And as part of our, I believe, our NetBrain test drive and our lab environments, we have that module there as well, so you can have a look at that as well through those resources.
And I just want to intents does not get charged for additional using the application assurance modules. So you can run unlimited intents without having the intent-based automation module in the application assurance module.
That's correct.
The next question is MOS score considered as well with quality of service?
So at this point in time, when talking about our path calculation and application assurance, MOS score is not considered as part of those calculations at this time.
Okay. But you can program in any of the quality of service conditions that you want to verify through NetBrain. Okay, and yes, this webinar will be recorded and sent out to you after we conclude here. I'm just going to stay on and see if there's any more questions coming for another minute or so. Question just came in. Will there be any future failure or outage prediction algorithms on the NetBrain platform? That way I could schedule my outages.
At this point in time, there has not been anything announced with regards to this type of functionality. But I would keep watching NetBrain. We're always innovating the way we do things, so you never know what can happen in the future. But at this point in time, that is, nothing's been announced.
Okay, I don't see any other questions, so I think we can go ahead and wrap up, and hopefully you can find any more information that you're looking for on our website. Thank you so much. Appreciate it.